We made it.
Some could argue that. Okay, so we talked about simultaneous solutions. And the way we did it yesterday was graphing from a table slash graphing whichever way you could. But the goal was to find where they crossed. Today, we kind of discuss what are the possible things that could happen when you have simultaneous solutions. So there's actually three different things that can happen. Now, this first one, when we have one solution, that's going to be like almost all of them. The second one happens rarely, and it's basically when the two lines are exactly the same line, so they're on top of each other. And then the third one is when they're parallel, which I know you're probably pretty familiar with parallel. I'll give you a moment to write these down. You do not need to write this info if you don't want. Really, the important thing for you guys is to write down how many solutions there would be and a picture of it, and then I'm going to write some information underneath after we get there. But so those words underneath aren't really that important. Actually, what I can do, there, then you won't accidentally write down the words. Wait, where'd the roller go? Oh, yes, Ava. Roll, please. 29 is Aaron. Aaron, do you think you could help me figure out what would be easiest for me to ask first? Probably the third one. How do we know when two lines are parallel? Do you remember this fact from before? I think you did it in geometry and algebra.
Oh, they never cross.
They never cross. In terms of their equations, like say we don't get to look at their pictures, what would their equations look like if they're parallel?
I have no idea.
That's okay.
They have the exact same solution except with the integers. They're like they have the exact same equation except for different integers.
You mean it correct. I think you can't think of the correct word.
They have the same slope.
Same slope. But that's exactly what you were saying. So they'll have the same equation but different y-intercept. So if two lines have the same slope, different intercepts. I better write y-intercept. I was just going to say different b.
When is our test on this information?
When we get done.
So will it be like next week, the week after?
So it'll most likely be the Monday, Tuesday to October 2nd, October 4th, 5th.
So is that,
4th, 5th. Right now, it's a 2-day test, because there's 2 parts to it. And up on the calendar, I have it on that Friday, but it'll probably be that Monday, Tuesday afterwards.
so that's not next week, week after?
Correct,
Okay.
yes. Eleven. 1, 2, 3. Oh, shoot, I'm learning to go away. Hank. Okay, so I didn't really discuss this one too much. So the same slope, I think most everybody kind of gets. That makes them look the same. The different y-intercepts just means that they cross at different spots, so that's why they're separated. If you have 2 lines that are directly on top of each other, and we're looking at their equations, what would we look for? I mean, there's different things you could say, but.
Like if they have the same line, just like the x.
Sure. So these will be exactly the same equations. And in terms of, this is kind of what we're focusing on for today. They'll have the same slope, same y-intercept.
Fourteen.
14 is, Zeno's not here. Good catch. 3?
23.
23, oh, that's very different. 23 is cadence. So I started off with these 2 because I think they were probably easier for everybody to describe ahead of time. Now that we've talked about these 2, if 2 lines are going to cross exactly once, what characteristic are they going to have? Like looking at this type of info.
We have the same. Well,
Okay, that's all right. Do you want me to get a drink so you can confer with people around you? Okay, I could do that. Or just look at the pictures.
different for both things.
Close. So the y-intercept actually doesn't matter at all for this one. So if 2 lines have different slopes, they automatically will cross once. And if they have different slopes, we generally don't even pay attention to the y-intercept because it won't matter. So the y-intercept could be the same, could be different, but it doesn't matter. So in terms of if I was just teaching you guys, I would have started with this one, but I think it was easier to identify on those, kind of working backwards. So here's what we're gonna do. We're not gonna be given pictures, so that's kind of why I'm discussing the info about them. We're just gonna be given the equations. First thing we're going to want to do is compare their slopes. So if we're looking at their slopes, if their slopes are different, automatically we know they'll cross once. If their slopes are the same, then that either means that the 2 lines are on top of each other or are parallel. Now it's usually super easy to tell if they're the same equation because they're the same thing written. Technically, when they have the same slope, we're going to compare their y-intercepts. If their y-intercepts are the same, then it's the same line. If their y-intercepts are different, it's parallel. But that's kind of the order we're going to go. So here's what it's actually going to look like. Yeah.
Can you go back just one question? So on the first one, the part where the lines cross, that's gonna be the solution, right?
Yeah, that'll be the simultaneous solution.
Okay.
That's what we did yesterday.
Yeah.
So today was kind of just talking about how there's different possibilities that can happen. Ava, did you pre-roll the next person?
35, then we have that.
Yeah, you're right. I don't think we only go up to 31 in here. That's okay, whenever I do it, it keeps to shoot it straight up. What?
1.
I thought it was gonna be 37 for sure. What? Oh, I don't know why I'm looking. Jaden,
Wait, what? Oh!
that's you. That was a pretty awkward time to be caught on your phone.
Oh, wait, no, I was caught on my leg. It was bleeding.
Oh, that's worse. You need a Band-Aid?
Can I call in help with his?
Yeah, I haven't asked anything yet though.
Oh. You didn't ask me anything?
No, I didn't ask any question. I said your name. That's pretty much it. I'll ask the question, and if you still want help, you certainly can. Okay, so we've got two different equations. Do you remember how we should write them so that we can tell what their slope and intercept are?
You subtract the variables?
Well, I was asking you. That sounded like you were asking me.
Uh,
You're actually not far off. I mean, like, you're pretty, I'll get a drink. I think he's looking for help, but I don't think I think they're trying not to give you help. It looks like they want you to struggle.
Yep.
Alright, subtract 2x from the bottom, and then up from the top, and then,
They gave you good help. So the key thing is knowing what you're trying to do. You gave me the correct step. Is there anybody in here, without just calling on somebody particular, why are we subtracting 2?
To put it in y equals and put
Okay, good. If you make the equation say y equals, it's going to automatically give you the slope and intercept. So if you solve for y, that's what we're trying to do each time. Solve for y. When you write an equation like that, it automatically will just give you the slope and intercept. Okay, so subtracting 2x was the correct step. Okay, do you want a Band-Aid?
oh yeah, I'm kind of messing with her right now. Oh, shall I run up there?
No, it's fine. I couldn't tell if you wanted one or if you. Okay.
I didn't thought the same one too.
So the next part is just a little detail. I can write 3 minus 2x. It's not wrong, but I bet you some people might get confused by that if I write it like that. Do you guys remember how to tell which one is the slope, which one's the y-intercept?
The x is the slope and the number you're adding or subtracting is the y-intercept.
Good. The number that's on the x is your slope, the number that's by itself is the y-intercept. So you can write them whatever order you want, and as long as you know the difference, that works. I know some people, it kind of throws them off. So for some people, you might just always want to write the x one first, and the regular one second. And if that's the case, go for it. I'll leave it like that just for purposes of talking about it. Okay, so that one definitely requires a lot more work. We should probably roll. We should probably definitely roll and have something to do to work on this next one. 12. Sean. Can you help me figure out how to get y equals alone on this one? Okay, good start. Good start. I'm going to remove the 9 by subtracting it because it's positive. So then this is going to say 6x minus 9, because I can't put them together, equals negative 3y. Good first step. Who's the second person? Unless you want to keep going. Okay. Chi-Ling. If we're trying to get y all by itself, there's only one step left.
Minus 6x to the other side?
How come?
Because you want the two x and y's to the other?
Oh, back, that's what we did yesterday, you're right. And that would work if we're trying to graph it. So for us, what we're trying to do is we want to make it so that the y is all alone by itself, kind of like this. So that we just call that solving for y. This one is close. This one is close. It's the only thing that's off is it says -3 times y. So you know how I could cancel -3 times y?
Would you divide by itself?
Perfect. So divide by -3. I divide by the item I want to get rid of. Now on the left-hand side, this can be confusing. This is probably just reminding you from previous years. You can either divide the whole side by -3, or you can divide each thing by -3. I think you guys would have an easier time dividing each thing. Well, it's not that special. Okay, so y equals 6 divided by -3 would be -2. -9 divided by -3 would be +3. Okay? Three? Alex. Oh, it's gone. No. Oh, that is where Alex sits though, isn't it? I have to take attendance. That definitely reminds me. Okay, you can go back. You can go back.
Oh,
18? Bryce. So our whole goal was to get the equations so that we could compare them. Let's look at the slope first. Is the slope the same or different?
Same.
Okay, so slope is same. How about the y-intercept?
They're the exact same one.
So y-intercept is same,
Yeah.
so they're the exact same line. No, same, not same. Our goal was to answer how many solutions there would be. So if they're the same line and they're on top of each other, how many solutions are there gonna be? Infinite. So there'll be an infinite number of simultaneous solutions. And it's super annoying to write that. Yes,
We find the y-intercept in that.
say it again.
How do we find the y-intercept in that?
The y-intercept is gonna be the number by itself. So on both of these, that's the y-intercept. How are we doing on this one? Is this one okay? Questions on how it's set up? They're obviously not super fast, depending on how quick you are at rewriting things. Okay, we get done at 28 today. You guys want to do one together? Do you want to go write the homework? I don't care.
Do one together.
I agree. Yeah. So I did mine, wait, I actually have a question.
Yep, go ahead.
So I did mine in a different way, and I obviously got the wrong answer, but I'm confused with why. So I had,
Okay, I thought you were gonna say I did it differently, but got the right answer.
so it's probably just my algebra, I erased it, but I had 3y plus 6x plus 9. I subtracted 6x.
So wait, so you get 3y plus 6x.
Oh, I'm sorry, so I had 6x equals 9 minus 3y. So I added 3y to both
Yep.
sides, and then I get 3y plus 6x.
Yep.
After that, I subtract 6x.
Yep.
And I get y equal, or 3y equals 6x.
Negative 3.
Negative 3y.
Oh, no, I'm sorry, you're right, 3y.
So y equals 6x plus 9.
It should be negative 6x plus 9.
Oh, yeah. So then from that, can I just go from here?
Yeah, that way works.
Okay. I didn't get the correct answer.
Yep, no, you can do that. Why don't you guys just pick the one on the left? Pick the one on the left, because that's probably the most straightforward. And your goal is just to figure out how many times they would cross, which is either gonna be 0, once, or an infinite. Go ahead. Oh, you're talking about something else? No. You're supposed to. Well,
Yeah, so you're.
I feel like we should talk to your counselor then, huh? Okay, that's a good plan. I know your senior year is on college side, it's not district.
Do you have economics? Maybe that's why.
Say it again?
And then definitely that's there, so mark your hazard.
Like parallel
You can if you want, you don't need to. So that's just more of like a mental thing, like if you know it's gonna be parallel, how many circuits?
Set up your equation, so have 3x plus y.
It's possible.
And then, so you have your y, so then you're gonna subtract that rate from walk as
Okay, I'll do this first one quickly so you guys have some time to work.
That's gonna be a negative.
The first equation, I want to subtract 3x. So then we got y equals 3 minus 3x. And again, you can write it as negative 3x plus 3. The bottom one, to get y equals, I would subtract 2. And so then this is y equals negative 3x minus 2. And the thing we are focusing on is the slope. So we focus on the slope first. And on this one, they're both the same. So in that case, the lines are either going to be parallel or they're going to be on top of each other. And to figure out which one it is, then you look at the y-intercept. And they are different. So as soon as they are different, that's telling you the two lines are parallel, whether you're visualizing it or not. These would have 0 simultaneous solutions. They would never cross. And that's all you're doing today compared to yesterday. Today is just talking about how many times they would cross, how many simultaneous solutions. Ooh, why is that bar? Okay, like I said, I wanted to give you some time to work so that you could ask questions, just get things done. We haven't had much actual work time in here since it's kind of been like notes most of the time. Yes. What? Class is done at 28.